the campers. Yeah, welcome to Math Booth Camp. Yeah, please remember to like, share, and subscribe. So today we'll be looking at matrix multiplication. Now this is something that is very strategic and it's an arithmetic. It follows a particular order. So please pay keen attention and please remember to practice as well. So when multiplying matrices, there are certain things to consider. Alright? So for example, once you see two matrices beside each other, it means multiplication. Okay? Like this. Alright, here we have the multiplication sign. So I'll show you another example further on. So if we look at the order of this matrix, the order of this matrix is a 3 by 2 matrix. So we have 1, 2, 3 rows and 2 columns. So a 3 by 2 matrix. This matrix here is a 1, 2 by 1, 2, 3. A 2 by 3 matrix. Now if you notice that these two numbers here are the same, when these two numbers here, after writing the orders of the matrix, if you realize that the two numbers in the middle here are the same, it means that it is compatible for matrix multiplication. They can be multiplied. Okay? Afterwards, if you look at these two numbers at the end here, you recognize that it gives the result. So it gives the order of the result of the matrix multiplied. Okay? So let's look here. So here's a rule for matrix multiplication. If you identify the order of the matrix and the order of the next matrix that it is being multiplied to, and the two middle numbers here are the same, if they are equal, it means that it is compatible for matrix multiplication. Alright, so if they, and these two end numbers tells you the dimension or the order of the matrix, the product of the matrix. Here we have matrix AB. So it tells us the order of the matrix AB. Alright? So let's get into multiplying matrix. So the method of multiplying the two matrix here is first identify that when multiplying matrix we use row by column. So once we're dealing with matrix, we multiply the row by the column. So it's a row of the elements in the first matrix by the column of the elements in the second matrix. And given that these two matrices can multiply because these two middle numbers are the same for the order, it is compatible for matrix multiplication. So let's multiply the row by the column for these matrices. Okay? So the first element in the row here is 3. So let's multiply 3 by the first element in the column. So if we were to highlight the element in the row versus the element in the column. So let's go. So we would end up with, alright, so we would end up with 3 multiplied by 3 plus, what would we multiply now? 4, which is the second element in the row, by the second element in the column. So it's 3 multiplied by 3 plus 4 multiplied by 6. Alright? Is that clear? And then we will continue multiplying the same row by the next column. Okay? So it's 3 plus 4 times 6. So that's giving us the first element there. Then we're going to multiply this row by the next column, which is 1 and 9. So let's multiply that. So it's going to be 3 times 1 plus 4 times 9. And then now we're going to multiply this row by the next column, which is 5 and 7, the elements with 5 and 7. So let's go. We're going to multiply 3 times 5 plus 4 times 7. Are we finished multiplying this row by all the columns? Yes. So now we're going to move on to multiplying the second row now by the first column. So what would we end up with now? 7 times 3 plus 2 times 6. And then we're going to go to the other elements. Alright, so the second row now by which column? Very good, by the second column. So it's going to be 7 times 1 plus 2 times 9. And given that we're finished multiplying the second row by the second column, we're going to now multiply the second row by the third column now. So it's going to be 7 times 5 plus 2 times 7. And remember, it's always the first element in the row by the first element in the column plus the second element in the row by the second element in the column. Okay? That's the order. So it's going to be 7 times 5 plus what? 2 times 7. And then to do the same thing, pay attention. What are we going to multiply now? We just did the first row, second row. Now we're going to go to the third row. And now we're going to multiply the third row by the first column, which is 5 and 9 by 3 and 6. So that will give us 5 times 3 plus 9 times 6. Alright? And then we go to the next column, which is 1 and 9. So this is 5 times 1 plus 9 times 9. 5 times 1 plus 9 times 9. Alright? And then we're going to move to the next column. So it's the same third row, but now we're going to go to the third row times the third column. So we would end up with 5 times 5 plus 9 times 7. And there we have it. Multiply all the elements in the first matrix, the row of the elements in the first matrix, by the columns of the element in the second matrix. And there we have it. So what would be our result here? Our result would end up being, alright, 3 times 3, 9, plus 6 times 4, 24. 9 plus 24 would give us 33. Alright, then we have 3 times 1 plus 4 times 9. That's 3 plus 36 would give us 39. And then we have 3 times 5, 15, and 4 times 7, 28. Okay, so that would give us 15 plus 28 would give us 43. This would be 7 times 3 plus 2. The matrix multiplication of a 3 by 2 matrix by a 2 by 3 matrix. And if you notice, we have 3 rows and 3 columns. So therefore, for this matrix, we realize the order is a 3 by 3. And remember what we had predicted? This would have been for the result, the order of the result, 3 by 3. So let's look at one more. So if we multiply this matrix, what is the order of this matrix? A 2 by 3. And the order of this matrix is a 3 by 2. So yes, they are compatible for matrix multiplication as the two middle numbers are the same. And the result should end up being a 2 by 2 matrix. So we multiply the first element by the first element, the second element in the row by the second element in the column, third element in the row, and the third element in the column. And we end up with this. And this would be the result. A 2 by 2. 2 rows and 2 columns. 2 by 2 matrix. Now, let's try and multiply these two matrices. So we have matrix A, 1, 2, 3, and 5. Matrix B, 1, 2, negative 1, 1, 4, and 0. Now, let's find the product of matrix AB. So, matrix AB. So, if you notice, the matrix which comes first is the one that we put first. So, we put A first, and then we put matrix B. So, when we are finding the product, we ensure that we have it in that order. Okay? Alright, so now we are going to multiply these two matrices. Now, what's the order of matrix A? The order of matrix A is a 2 by 2. Very good. And what's the order of matrix B? Yes, a 2 by 3. Are these two matrices compatible for multiplication? Yes, they are. Because as you notice, these two middle numbers are the same. So yes, they are. And what would the result of AB be? What would the order of the matrix AB be? The order would end up being a 2 by 2. 2 by 3, sorry. Because we look at these two n numbers to know what the order will be. So let's multiply matrix A times matrix B. Remember, when multiplying a matrix, we multiply the first element in the row by the first element in the column, multiply by the second element in the row by the second element in the column. It's always row by column. So let's go. Let's do this fast. So it will be 1 times 1 plus 2 times 1. And then we go for the first row times the second column now, which is 1 times 2 plus 2 times 4. And then the same row we're going to multiply by the third column. So that would be 1 times negative 1 plus 2 times 0. And then, are we finished with this row and all the columns? Yes. So now we're going to go to the second row and multiply by all the columns. So it's going to be, so our result would end up being this. After carefully multiplying every row of the first matrix by each column, we would end up with 3 times negative 1, 8, 26, negative 3. Okay? And if you notice, what is the order of this matrix? A 2 by 3 matrix, just as how we predicted. Alright, campers? Thank you for watching. Please remember to subscribe and share.